Hello, hi everyone. Welcome to the student brand. Hello, students. Welcome to the class. So, this is your Shiva sir. Today we are going to discuss about light reflection refraction CBSE grade 10 physics. Okay, so light reflection and refraction CBSE grade 10 physics. Okay, so those who are there in ninth standard, so going to 10th for them. So big announcement. So for you only, I'm starting the classes. Live class interaction sessions will be there. Okay. So course only for 1,000 rupees. Okay. 4 chapters, notes will be provided. So PDF is there. Okay. So PDF is available. I'll share the PDF and discussion will be there. And so remaining from the textbook and important questions are there, notes is available. Okay, so we'll discuss all those points. That's why I'm starting the course. Live classes will be there. Okay, so those who are there in 10th class, so CBSE grade 10 physics, CBSE grade 10 physics. Okay, so exclusively for you, four chapters, light reflection and refraction. Okay, so what are the 4 chapters? Light reflection and diffraction, human and colorful world, electricity and magnetic effects of electric current. Okay, so 4 chapters. And coming to the next one, notes PDF. And coming to the third one. Okay, so questions questions will be there. Questions will discuss, and timely interaction will be there. Doubts clarifications will be there. Doubts clarification, and continuously guidance will be there from my end. Continuously guidance will be there from my end. I hope it is very clear. So you can check. So in the okay, so current who wrote the exam this year 10th standard. So whatever we discussed, those questions are there in the exam. Like so magnetic effects of electric current, one question when you are sitting in the room, so electron beam is moving from back to front, that question is there. And coming to hypermetropia, as it is the sequence also came. Okay, so what is hypermetropia, causes of hypermetropia and correction diagram, as it is line, I many times I'm explaining the same. Okay. So like that, those are attending the class also. After exam, they informed to me. So paper was easy. So whatever we discussed, those questions are there in the exam. Okay. So current carrying near to the conductors, magnet will be more away from the conductor, magnet will be less. Likewise, so there are many questions. There are many questions if you discuss like that. Okay. So now for upcoming 10th class, upcoming 10th class, I'm starting the online classes. Interactive sessions will be there. So okay, so in online class interactive sessions will be there. So the course will be only for 1,000 rupees. Okay, 1,000 rupees. Those who are interested, you can take the number and do WhatsApp. Okay, you can do WhatsApp to that number. Already I mentioned. So again, I'll write 98 498 128 04. So this is the number. You can do WhatsApp. Okay, WhatsApp to this number. WhatsApp number. Okay. So WhatsApp number, do WhatsApp to this number. Then okay, so we'll get all the details, everything. And grade 11 also, those who are studying grade 11, WhatsApp number. Grade 11 also for you only. Those are their current, those who completed the exams. For you also, I'm starting the classes, live interactive sessions, live interactive sessions. So interactions will be there. Okay, grade 11 topics along with the JE. Okay, HC Verma, Singh, and DC Pandey. Okay, so all these reference books, from the reference books we'll discuss, and PYQs also will practice PYQs, right? So you can join to the classes. Those who are interested, those who want to attend, those who want to join the classes, those who want to take the classes. So from so 25th. So today, I hope today 17th. Today 17th. Okay. So I'll take the references until 20. So continuously information will be there. 20 until 20 I'll take. Okay. So until 20, until 20 of this month, I'll take all the references. Okay. Further, if you want to suggest anything also regarding the classes, regarding the timings, regarding the price, if you want anything, okay, so you can give suggestions. You can inform to me. You can let me know your concerns. Based on that one, again, we'll rewind the things from 20 onwards. Okay. So from 20 onwards, right from 20 onwards, again, so final call will be taken. So when classes will be there, how the classes will be conducted. So if you have any concerns regarding this also, you can ask doubts. You can ask doubts. Okay. Evening time only classes will be there. Online classes. Evening time only. Okay. So around this time. Around this time. Okay. So all the classes will be conducted. Interactive sessions will be there. Okay. Everything. The syllabus, entire syllabus will be covered. So PYQs will be, we will discuss PYQs. At the same time, from reference books also, we'll do questions. Okay. So this is about our course. Okay, I'll take, I'll teach. So grade 10, 11th, 12th, JE NEET topics. And right from 6th standard, those are there, those are studying in 6th, 7th, 8th, 9th, and 10th. For you also, okay, so foundation classes also there. Foundation classes. Okay, you can check the price. Understood or not? Foundation classes also I'm starting. Foundation classes also from 6th standard, 7th standard, 8th standard, 9th standard, and 10th standard. Those are okay. Those who want to prepare for JE and NEET, for them. So I'll be conducting foundation classes. Okay. So the price 3,000 rupees for grade 11 students. The price is 2,500 rupees. Already it is there in the banner. You can check. Okay. So you can check the number, you can contact to that number. You can contact to that number. You can do a message. Okay, so if you are waiting for the classes, live interactive sessions, okay, so you can join to that classes. So one to one, if you want a particular topic also, it is available. Okay, let me know which topic you are going to ask. So which topic you want. Okay, in the coming videos, next live classes, let me know. Then by that also we'll discuss, right? So in the YouTube, whenever I'm taking live classes, you are attending. So if you take the course, if you take the course, continuous support will be there. Okay, continuous guidance will be there. Classes will be there. Okay. Time to time classes will be there. Syllabus will be covered. PYQs will be discussed. Understood? So from reference books, questions will be solved. So all these things will do. Will do. Okay. So live interaction will be there. So if you join to the course, if you join to the course, okay. So that's enough. If you have any doubts, still if you need more details regarding the course, everything, you can note down this number. This is the number. You can do WhatsApp only. So you can do only WhatsApp, right? So you can send a messages to this number. So I'll interact with you all. So I'll talk to you. So I'll message you regarding your doubts and everything. Okay. Let me know still if you need anything. Okay, regarding the classes, regarding the timings and all. And one-to-one classes also available. One-to-one classes also available. Okay, foundation classes or grade 10 classes and grade. Okay, so whatever the price I mentioned, that is overall. Okay, so like in the group, like online classes. So one-to-one, if you want, so you can let me know. Regarding that also, I'll let you know. Okay, one-to-one classes if you want, I will take one-to-one classes also. So the price will be different. Price will be different for one-to-one, and based on okay, so your requirements, your okay things, everything we will discuss one-to-one classes. So if you need one-to-one classes, you can contact that number. Okay. So regarding the details and everything, so we'll discuss. Okay, now we will start the class. We'll start the class. So I hope you can check the classes. You can attend the class and check the classes. Okay, so then you can join to the course. Okay, you can check my videos. So completely it's related to subject point of view only. So each and every class and in-depth discussion will be there regarding the particular topic. Okay, based on that, questions will be there. So questions also will do practice. Everything we will do it. Right? Yes. Let's start. Let's start. So light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Okay, well, light incident on the surface. So now we will discuss about reflection of light. Reflection of light. Reflection of light. Reflection of light. Okay, so I'm taking here. This is a plane surface. Plane surface. The light ray which is incidenting on it. This is the incident ray. Incident ray. Incident ray. The light ray which is reflecting back is called reflected ray. Reflected ray. And the light ray which is perpendicular to the plane surface, that is called normal line. The light ray which is perpendicular to the plane surface is called normal line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Okay, and here you can observe the angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. Okay. So this is about the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. And here you can observe incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. So angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line or initial direction of the incident ray is called angle of deviation. Okay, coming to loss of reflection. Coming to loss of reflection. Loss of reflection. Okay, coming to loss of reflection, point number one. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Once again, incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Now you can observe here. Now we can observe. Now we can observe, right? So now you can take here angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay. From loss of reflection, from loss of reflection, from loss of reflection, we can observe that from loss of reflection. So angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. And angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of incidence. I hope it is very clear. Understood or not? Next one, we can also write angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation equal to 180 minus 2 angle of reflection. I hope it is very clear. Understood or not? Right? Now you can observe, sir. Sir, how you wrote this one? So I have one question. Sir, how you wrote angle of deviation equal to 180 minus 2 angle of incidence? So from loss of reflection, angle of incidence is equal to angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. So that's why angle of deviation equal to 180 minus 2 angle of incidence. And angle of deviation equal to 180 minus 2 angle of reflection. Instead of angle of incidence, if I write angle of reflection, then I'll get angle of deviation equal to 180 minus 2 angle of reflection. I hope it is very clear. Understood or not? Yes. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, coming to loss of reflection. Incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. Okay. Now, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay. Now, from loss of reflection, angle of incidence is equal to angle of reflection. Right? So here you can take angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. So instead of angle of incidence, if I write angle of reflection, I'll be getting angle of deviation equal to 180 minus 2 angle of reflection. Is it clear? So I hope it is very clear. Next, so we'll discuss about regular reflection and irregular reflection. 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 Yes, you can take regular reflection. So actually, right from starting onwards, right from my channel, right from starting of my channel, so I'm doing with the different customs. So if you want to know more about so this one, you can check the channel. Once you can check the channel, entire channel, then you'll get to know. Okay, next one, we will discuss about regular reflection and irregular reflection. Regular reflection. Regular reflection. So what is a regular reflection? Regular reflection is nothing but so incident light rays are parallel. So I'm taking the plane mirror. This is the plane mirror. So these are the incident light rays. Okay, those light rays are parallel to each other. That's why incident parallel beam. Okay, so if light rays are parallel to each other, then we can say beam, right? Parallel beam. If number of light rays are parallel to each other, so that is incident parallel beam. And the reflector light rays are also parallel to each other. Reflected number of light rays together, it is called a beam. If those are parallel to each other, parallel light rays. So parallel beam, incident parallel beam. Next one, you can say the light rays, reflector light rays are also parallel to each other. Reflector light rays are also parallel to each other. Understood or not? Reflected parallel beam. Reflected parallel beam. Okay, single light ray is called ray. Number of light rays parallel to each other. Then that is called beam. And this is a smooth surface. Okay. Regular reflection takes place on smooth surface. Whereas irregular reflection takes place on rough surface. So here you can observe this is the rough surface. Understood or not? This is a rough surface. Incident light rays are parallel. These are the light rays. Okay, so here you can observe. These are the light rays. So incident light rays are parallel to each other. Incident light rays, but reflector light rays are not parallel to each other. These are called, okay. So reflector light rays. Understood or not? Reflector light rays. So incident light rays are parallel. Then reflector light rays are also parallel to each other. This type of reflection is called irregular reflection. Irregular reflection takes place on rough surface. Okay. Irregular reflection takes place on rough surface. So this is a rough surface. Irregular reflection takes place on rough surface. I hope it is very clear. Understood or not? Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Irregular reflection or diffused reflection. Irregular reflection or diffused reflection. I hope it is very clear. So irregular reflection or diffused reflection, that is called well, light rays are incident on it. Incident light rays are parallel, but reflector light rays are not parallel to each other. This type of reflection takes place on rough surface. Then this type of reflection is called irregular reflection or diffused reflection. Irregular reflection or diffused reflection. I hope it is very clear. Regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. Right? So I hope it is very clear. So this is about regular regular and irregular. So coming to the object and image. And here related to this one, there is one question. A wall reflect light rays and a plane mirror also reflect light rays. What is the difference of reflection? What is the difference in the reflection? A wall also reflect light rays. A plane mirror also reflect light rays. What is the difference in their reflection? Say wall reflect irregular. So on wall, irregular reflection takes place. On wall, irregular reflection takes place. On plane surface, on plane mirror, regular reflection takes place. Okay. And one more question. So where irregular reflection takes place? Example. So irregular reflection takes place on cinema screen and wall and book. Irregular or diffused reflection. Coming to regular reflection, where regular reflection takes place on highly polished smooth surface and still water surface of lake. Still water surface of lake. Okay, if water is not moving, it is still surface. Then regular reflection takes place. I hope it is very clear. Understood or not? So this is about regular reflection and irregular reflection. And one more thing, when the light ray is passing along the normal line, so there is one question. There is one question. Okay. So here, when light ray is passing along the normal line, so here you can observe, this is a plane mirror. If the light ray is passing along the normal line or moving along the normal line, so what is the angle of incidence? So they will ask this question also. So question number 1, what is the angle of incidence? Question number 2, what is the angle of reflection? Question number 3, what is the angle of deviation? So what is the angle of incidence? What is the angle of incidence? Angle between incident ray and normal line, right? Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And angle between reflected ray and deviated line is called or initial direction of the incident ray is called angle of deviation. Okay. So here angle of incidence, incident ray along the normal line, reflected right also. So angle of incidence is 0, angle of reflection is 0, angle of deviation is 180 degrees. Okay, so very important question. If the light ray is passing or moving along the normal line, if the light ray is passing or moving along the normal line, angle of incidence is 0, angle of reflection is 0, and angle of deviation is 180 degrees. Is it clear? Yes. This is one question. Okay, so next one. Next one is object and image. Object and image. So here I am taking the plane mirror. Okay, so the light rays are coming. After reflection, those light rays are meeting at one point. like here. Here you can observe these are the reflector light rays. Reflector light rays. Reflector light rays are meeting at one point. Reflector light rays are meeting at one point. Understood or not? Reflector light rays are meeting at one point. So the point of intersection of reflector light rays is called real image. So what is this one? You can observe here. So this is I1 incident ray, I2 and R1, R2. So here R1, R2 are meeting at one point. Reflector light rays, directly reflector light rays are meeting at one point. So that is called real image. And if you are extending these incident light rays, extended incident light rays are meeting at one point, that is a virtual image. That is a virtual image. The point of intersection of extended, the point of intersection of extended incident light rays is called a virtual image. The point of intersection of extended incident light rays is called virtual image. Right? So now you can take one more. You can observe one more. So here I am taking like this. From one point, the light rays are moving from this point. After reflection, these light rays are moving away from it. Okay, if you're extending these light rays, this is the real object and this is the virtual image. Virtual image. Hi, Chandrakant. How are you? Oh, very good. Hi, and Tanmay Setti, hi. Yes. Kupawara, thank you. Okay, now you can observe. So here, this is I1, I2, this is R1, R2. I1, I2, R1, R2. If you are extending the reflector light rays, here you can observe directly reflector light rays R1, R2. Those are meeting at one point. That's why it is called real image. Real image. And here you can observe, so we are extending the reflector light rays. Extended reflector light rays are meeting at one point. Their image is forming, that is a virtual image. Virtual image. I hope it is very clear, right? So, by observing these two diagrams, we can conclude that by observing these two diagrams, object and image. Object is real, image is virtual, object is virtual, image is real. By observing these two diagrams, we can conclude that object is real, image is virtual, object is virtual, image is real. I hope it is very clear, right? Yes or no? So if you observe these two diagrams, you can observe here. So this is a real image. R1, R2, reflector light rays are meeting at one point. And we are extending this incident light rays. Incident light, extended incident light rays are meeting. Their virtual object, this is virtual object. Here also image, you won't get right. This is a virtual object. Virtual object. So objects here, image is real, object is virtual. This is a real image. Image is real. Object is virtual. Object is virtual. And here you can observe real object. Real object. What about image? Image is virtual. Understood or not? So we can conclude like that. Object is real. Object is real. Image is virtual. Object is virtual. Image is real. Yes or no? Yes. So now we can take it. So nature of the image formed by the plane mirror will discuss. Nature of the image formed by the plane mirror. So now you can observe. Okay. So here, this the object. Height of the object is AB. AB. Okay. Height of the object is AB. Right. So from that, how many light rays are required to form the image of the object? So minimum light rays are required to form the image of the object. Minimum light rays are required to form the image of the object. So two. So one light ray I am taking like this. After reflection, it moves away from it. Another light ray is reflecting back. You can observe here. You can observe. Okay. Another light ray. This is A. And here one more light ray, and here one more light ray I'm taking here. So here this will be reflected. If you are extending the light rays, if you are extending here and here also, so these light rays and here. So this is A dash and B dash. A dash and B dash. I hope it is very clear. Yes or no? Now from this we can conclude that. So here this the object distance, the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. The distance between object to mirror is called object distance. And the distance between mirror to image is called image distance. And height of the object is equal to height of the image. So this is the height of the object. This is the height of the object, and here is height of the image. This is the height of the image. Height of the image. Okay. So now point number one. Object distance. Object is real. Image is virtual. Object is virtual. Image is real. Just now we discussed. Object is real. Image is virtual. If the object is virtual, image is real. So that is point number one. And coming to the point number two. Point number two. So what is point number two? Object distance is equal to image distance. Object distance is equal to image distance, and height of the object is equal to height of the image. And coming to the fourth one, magnification of the plane mirror is +1. Magnification of the plane mirror is +1. And coming to the fifth one, it also shows lateral inversion. It also shows lateral inversion. Lateral inversion. Okay, these are the points. Object distance is equal to image distance. Height of the, okay. So if object is real, image is virtual. If the object is virtual, image is real. Object distance. So object distance is equal to image distance. And the height of the object is equal to height of the image. And the magnification of the plane mirror is +1. Okay, so magnification is nothing but height of the image by height of the object. And also it shows lateral inversion. Sir, what do you mean by lateral inversion? Lateral inversion is nothing but the phenomenon of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. If you observe the ambulance, the letter written, okay, the letters written on the ambulance, so it will be in the form of mirror image. Once you see in the rear view mirror, once you observe in the rear view mirror, then you will get to know clearly the ambulance word. Okay? Yes or no? It will be in the form of mirror image. So that is what lateral inversion. What is the lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. I hope it is very clear. Understood? I hope it is very clear. Right? Yes. So check once. These are the points. These are the points. Now we will discuss about spherical mirrors. Spherical mirrors. Spherical mirrors. Spherical mirrors. Okay. The mirror which is in the form of curved surface. So completely we'll discuss about spherical mirrors. The mirror which is in the form of curved surface. The mirror which is in the form of curved surface is called spherical mirror. Okay, so there are two types of spherical mirrors. One is concave mirror. One is concave mirror. Concave mirror. Another one is convex mirror. Convex mirror. Convex mirror. Okay. So concave mirror is also known as converging mirror. So why you are calling concave mirror is a converging mirror? Because when light rays are incidenting on it, so here you can observe whenever light rays are incident on it, after reflection, those light rays are meeting at one point. After reflection, so this is the bird. Whenever light rays are incidenting on it, so those light rays after reflection, those light rays are meeting on the principal axis, are coming closer to the principal axis. So that's why it is called concave mirror is also known as converging mirror. So whereas convex mirror is also known as diverging mirror. Sir, why you are calling convex mirror is a convex mirror is a convex convex. This is a concave. Concave. Concave mirror. And here convex mirror. Convex mirror. So here convex mirror you can observe whenever after reflection, if you are extending the reflector light rays, those reflector light rays, extended reflector light rays are meeting at one point. So here always will get virtual, erect and diminished image in convex mirror. In concave mirror, so we'll get two types of images, real inverted and virtual erect images. Understood? I hope it is very clear. So this is about concave mirror and convex mirror. Concave mirror and convex mirror, right? So now we will discuss about ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirrors. So we'll discuss. So before that, so we'll discuss about terms related to spherical mirror. Terms related to spherical mirror. Understood? So I'm taking this a concave mirror. Actually, it is a part of the sphere. It is a part of the sphere. The center of the imaginary sphere. The center of the imaginary sphere in which mirror is a part. The center of the imaginary sphere in which mirror is a part is called center of curvature. Actually, it is, we are taking a small portion. That's why it is called curvature. Okay, from the sphere, we are taking a small portion. So that's why it is called a curvature. Okay. So this is a point, center of the imaginary sphere in which mirror is a part. Okay, so it is a small portion, that is a curvature, and the midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. So first one is center of curvature, second one is pole, third one is principal axis. Principal axis. I hope it is very clear. Principal, principal axis, principal axis. And coming to the fourth one, the distance between center curvature to pole is called radius of curvature. The distance between center curvature to pole is called, the distance between center curvature and pole is called radius of curvature. Okay. So if the light rays are coming after reflection, those light rays are meeting at one point. After reflection, if the light rays are meeting at one point, that point is called focus, capital F. Actually, it is called principal focus. Principal focus, simply we can say focus. So the distance between focus to pole, the distance between focus to pole is called focal length. Okay. The distance between focus to pole. So the distance between focus and pole is called focal length, small f. And the width of the reflecting surface is called aperture. Seventh one is width of the reflecting surface. Width of the reflecting surface is called aperture. I hope it is very clear. Understood or no? So once again, check all the points. So all those points. Say yes, what is your doubt? You can let me know. So you can check all the points. First one is center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. And midpoint of the mirror is called pole. Midpoint of the mirror is called pole. The line joining of center of curvature and pole is called. So nice question. Nice question. I didn't expect this. Hi. हिंदी में थोड़ा थोड़ा आता, so I'm trying to learn. I will learn. I have to learn. I will definitely learn for you all. Okay. So here you can see center of the imaginary sphere in which mirror is a part is called center of curvature. Midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. So the distance between center of curvature and pole is called radius of curvature. So after reflection, all light rays are meeting at one point of the principal axis, that is called, actually it is called principal focus. Actually that point is called principal focus. So in the simple word, we are telling, we are talking, we are pronouncing, we are using principal focus. Instead of principal focus, we are using focus. Simply we can say focus, right? Are you a scientist? Uh, I'm a physics teacher, so with a great, extraordinary, marvelous, amazing, outstanding, mind blowing, like so many words, with a dedication, with a determination. So all are mixed. So like that. So I am teaching physics. Okay, done. Come to the point. Center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The line joining of center curvature and pole is called principal axis. The distance between center curvature and pole is called radius of curvature. Current electricity. Yeah, of course. User ID 11131. Yeah, so definitely I'll take class on electricity, current electricity. Oh, are you original? Huh? Passion. Okay. Beyond passion, more than passion, any words are there. So we can use that. So sir, talk about current electricity. So yes, J also I'll take. So grade 11 topics are going on. You can check. So till now I almost units and measurements, motion in a straight line, motion in a plane, and loss of motion, work and energy, and work energy and power. So system of particles and rotational motion, rotatory motion, and after that mechanical properties of solids. Right? Yes. And yes, until that I explain. And so I'm going to explain about thermodynamics. So thermodynamics will discuss and scalars and vectors. Scalars and vectors also explain. So all the videos are there in the channel. Just go and check. Original profession. So I had great 10 years of experience as a teacher. All right. Yeah. Yeah. Original only. Original. Original. Yes. Okay. Done. So talk about current electricity. Yeah. Definitely. I'll talk. I'll discuss. I'll discuss about current electricity definitely because there are many videos regarding Grade-10 CBSE physics. There are many videos are there. So, but still, so you ask right? Definitely, I'll teach. So in our channel only, so you can once go and check the channel, then you will get to know. Okay, right. Come to the point. So these are the terms related to spherical mirror. So I am from Hyderabad. Okay, I am from Hyderabad. So next one, so we'll discuss about terms related to spherical mirror. These are the terms. One is center of curvature, pole, principal axis, the line joining of center of curvature and pole. And coming to the radius of curvature, the distance between center of curvature and pole is called radius of curvature. And coming to the focus. So after reflection, all light rays are meeting at one point on the principal axis. That is called actually, it is called principal focus. Simply, we can say focus. Okay. Then the distance between focus to pole is called focal length. And width of the reflecting surface is called aperture. Width of the reflecting surface is called aperture. I hope it is very clear. So is it clear? So actually, right from starting of the channel, once you go and check the channel, so from starting of the channel, I am doing with different costumes only. So I am not doing only for this live class, only for next, only for the previous. Not like that. Right from starting onwards, 2020. Okay, so my channel was started 2020. Still it is continuing. So now we are in 2026, right? So right from beginning onwards, I'm doing with the different costumes. So if you have time, just go and check my videos. Go and visit the channel. All the videos, like so many. So definitely you'll get amazing experience with the physics. Okay. So next one. So we'll discuss about ray rules. Ray rules of spherical mirror. Spherical mirrors. Or we can take spherical mirrors. Ray rules of spherical mirrors. So ray rules of spherical mirrors. So I'll do only two works. One is teaching. First one is teaching, and the second one is also teaching one. Okay. Only teaching. Right? So now concave mirror and convex mirror. Concave mirror and convex mirror. So concave mirror, so here you can take. So pole, focus, center of curvature, pole, focus and center of curvature. Okay. So light ray is coming from infinity, after reflection it passes through focus. So second one, light ray is coming from infinity, after reflection it passes through focus. And the second one, light ray is passing through focus, after reflection it moves towards infinity. And coming to third one. So this is the pole, focus, center of curvature. Light ray is passing through focus. Sorry. Light ray is passing through center of curvature. So again it retraces its original path, and coming to the fourth one. So light ray is so this is the pole, focus and center of curvature. Light ray is incidenting at the pole. After reflection, it moves in the same direction. Right? Next one. So this is a concave mirror. Next one is convex mirror. Convex mirror. First one is, so I'm taking the convex mirror. This is a convex mirror. So pole, focus, center of curvature. Pole, focus and center of curvature. So light ray is coming from infinity, after reflection. It moves away from the principal axis. So I'm only teaching online. So online batches are going to start. So you can check the channel banner. So those are interested to take the classes, you can check the channel banner. Okay. So for grade 10, grade 11, and right from 6th to 10th, those who need JEE NEET foundation classes also. So if you want, you can contact that number. So I given the number. Okay. So and you can observe. So see the number, you can contact that number. So regarding the classes of grade 10, grade 11, and right from 6th to 10th foundation classes. Okay. So okay. So one check and just send a message, drop a message regarding the classes. We'll discuss. Right. Now, so light ray is coming from pole, focus, and central curvature. Light ray is passing through focus. After reflection, it moves towards infinity and coming to third one. Coming to third one, here you can observe. So pole, focus, central curvature. Light ray is passing through central curvature. After reflection, it moves in the same direction. And coming to the fourth one, this is the pole, focus, central curvature. Light ray is incidenting at the pole. After reflection, it moves in the same direction. Okay. Okay, I hope it is very clear. Just check once. Just check once. So these are the ray rules of concave mirror and convex mirror. These are the ray rules of concave mirror and convex mirror. Okay. So these are the ray rules of concave mirror and convex mirror. Next one we will discuss about image formations. Image formations by spherical mirror. Image formations by spherical mirror. Image formations by spherical mirror. Okay, done. So image formations by spherical mirror. So now we will discuss about concave mirror image formations. Concave mirror image formations, right? Concave mirror image formations. So first one. So you are taking the concave mirror. Concave mirror. So this is the concave mirror. Concave mirror pole, focus, central curvature, pole, focus and central curvature. Okay, so one light ray. So I'm taking like this. After reflection, it meet at focus. Another light ray. After reflection. So object is at infinity. Image is forming at focus. Nature of the image is real and inverted. Size of the image is highly diminished. Or point size image. Point size image. Point size image is forming at focus. Point size image is forming at focus. Okay, so I'll try. So actually, so according to the schedule, I'm going through it. Grade 10, 11, 12. Okay, so and foundation classes for 6 to 10th, J and NEET. Foundation classes. Now, second one, concave mirror. Concave mirror. So pole, focus, central curvature. Pole, focus and central curvature. Okay. So object is placed behind central curvature. One light ray is passing through focus, another light ray is passing through central curvature. So the image is found between C and F. The image is found between C and F. Here you can observe. Okay, now you can see object is placed beyond central curvature. Object is placed beyond C. Image is found between C and F. Nature of the image is real and inverted. Size of the image is diminished. Nature of the image is real and inverted. Size of the image is diminished. Understood or not? Okay. So next one, coming to third one. Coming to third one, here you can observe. This is the pole, focus, central curvature. Pole, focus and central curvature. Okay. So object is placed at C. So image also will form at C itself. One light ray I am taking like this. After reflection, it passes through focus. Okay, another light ray is passing through pole, incidentting at the pole after reflection here. Okay, so now you can observe. Now you can observe object is placed at C. Image also will form at C itself. Nature of the image is okay. So you can so my number is there already mentioned. Okay, so you can contact that number. Just you can message me regarding the classes. If you want extra classes, you can let me know. So we'll discuss in the okay. We'll discuss regarding the classes. So you can check the number. You can check the number, right? So it is there in the channel banner. So once you go to the banner, so to that number, if you need any classes, okay, regarding any exam, just let me know. I'll take the classes, right? Yes. Now, object is placed at C, image also formed at C. Nature of the image is real and inverted. Size of the image is same size. Size of the image is same size. Okay. So I hope it is very clear. How to become physicist after BTech? That I have never. Okay. How to become physicist after BTech? You should have interest. That's enough. Nothing else. Then automatically get the path. You automatically so you can see the path. You should have interest to become. Okay. So it should be here. Okay, done. Come to the point. Fourth one. Now you can observe. So pole, focus, and central pole, focus, and central curvature. So now object is placed. Object is placed between C and F. One light ray I'm taking like this. Another light ray is passing through focus. One more light ray is incidenting at the pole. Then it will be reflected back. Then the image will form here. Okay, object is placed between C and F. Image is found beyond central curvature. Beyond C. Image is found beyond C. Nature of the image is real and inverted. And size of the image is enlarged. Size of the image is enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased. That's why it is called enlarged. That's why it is called enlarged. I hope it is very clear. Once observe the board. Once observe the board, I hope it is you can identify. You can identify. You can identify. So these are the ray rules. Sorry, image formations. These are the image formations by concave mirror. Concave mirror and six are there. Until four only we discuss. Fifth one is fifth one. Fifth one. Here you can observe this is the pole, focus, center of curvature. Object is placed at F. One light I am taking like this. After reflection passes, and another light ray is incident at the pole. After reflection moves. Now object is placed at F. Image is formed at infinity. Object is placed at F. Image is formed at infinity. Nature of the image is real and inverted, and size of the image is highly enlarged. Size of the image is highly enlarged. I hope it is very clear, right? So last one, sixth one is very, very important. So sixth one is very, very important. Sir, why sir sixth one is very important? Because so in the exam, if 3 marks question is there from the light chapter means this is the high priority question. Okay. So you have to give high priority to this question, to this diagram. Okay. So that much important it is. If you're reading light reflection refraction chapter, light reflection and refraction chapter, compulsory you have to focus. You have to concentrate little more compared to the remaining concepts, remaining topics, and remaining diagrams. So on this you have to spend little time to practice. Sir, why you are giving so much of introduction for one diagram? That one diagram, if that one diagram only comes in the exam, instead of practicing all the questions, if you are practicing this one question, there are chances are more to come this question. Okay, compared to remaining questions, I can say remaining topics, remaining diagrams. So like that much important it is. Very, 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 very important. Okay, so you can draw the diagram. I'm drawing here. This is the diagram. Concave mirror. What is one? Concave mirror. So pole, focus, center of curvature. Where object is placed? Object is placed between F and P. Object is placed between F and P. One light I'm taking like this. Another light ray is here. After reflection, we are extending the light rays. Okay, so we are extending the light rays. We are extending the light rays. We are extending the light rays. Okay, so here you can observe the object is placed between F and P. Object is placed between F and P. Image is forming behind the mirror. Image is formed behind the mirror. Okay. Image is formed behind the mirror. Nature of the image is virtual, erect, and enlarged. Virtual, erect, enlarged. Virtual, erect, enlarged. So, what is the nature of the image? Virtual, erect, and enlarged. Object is placed between F and P. Image is formed behind the mirror. Nature of the mirror is virtual, erect, and enlarged. Virtual, erect, and enlarged. I hope it is very clear. That much important it is. So expected for 3 marks. So you can put 5 star here. Okay, so 5 star. Understood or not? That much important it is. So next one we will discuss about convex mirror. Dun, 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 dun. Dun, 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 dun. So convex mirror. Convex mirror, convex mirror, convex mirror. So convex mirror, convex mirror. So now you can see this is a convex mirror, convex mirror, convex mirror. So this is the pole, focus, center of curvature. So object is placed at infinity. Object is placed at infinity. How many light rays are required? Minimum 2 light rays are required to form the image of the object. So here you can observe if you are extending these light rays. So object is placed at infinity. Image is formed at focus. Nature of the image is virtual, erect, and highly diminished. Highly diminished or point size. Point size image is formed at focus. Okay, so I hope it is very clear. So coming to the next one, that is second one. So next image formation of convex mirror. That is object is placed. Object is placed. So this is the pole, focus, center of curvature. Object is placed between pole and infinity. Okay. Object is placed between pole and infinity. One light ray I am taking like this after reflection. After reflection passes, another light ray I am taking. Incident at the pole, it reflect back. So if you are extending this light ray, the image will form between P and F. The image will form between P and F, right? So now you can see object is placed between P and infinity. Image is forming between P and F. Nature of the image is virtual, erect, and diminished. Sir, what is the meaning of diminished? Compared to the object, image size is decreased. Okay. So, so object is placed between P and infinity. Image is forming between P and F. Nature of the image is virtual, erect, and diminished. So what is meaning of diminished? Compared to the object, image size is decreased. Okay, I hope it is very clear. Right? Yes. So next one is sign conventions. Sign conventions. Sign conventions. Sign conventions. Sign conventions. Next one we will discuss about sign conventions. Sign conventions. Sign conventions. Sign conventions. Sign convention, sign convention. So here I'm taking the concave mirror. Concave mirror. So this is the pole, focus, center of curvature. So the first point is all measurements are taken from the pole. So we have to take all measurements from the pole. Point number one. We have to consider, we have to measure all the measurements we have to take from the pole. Coming to the second one, in the direction or along the incident rays, object distance, image distance, focal length, and radius of curvature all are positive. Opposite to incident rays, object distance, image distance, radius of curvature means all measurements are positive along the incident rays direction, or all measurements are positive in the direction of incident rays. So point number two. So opposite to incident rays, all measurements are negative. Okay, opposite to incident rays direction, all measurements are negative. So above the principal axis, above the principal axis, height of the image and height of the object, like measurements or distances above the principal axis positive, and below the principal axis, height of the image and height of the object negative. Anyway, object always will place above the principal axis. Only image will form below the principal axis, right? So object always will place above the principal axis. Okay. So now, now. Point number one. All measurements we have to take. You have to measure from the pole. So in the direction of incident rays, along the direction of incident rays, all measurements are positive. Opposite to incident rays, all measurements are negative. Above the principal axis, all heights like height of the image and height of the object positive, and below the principal axis, height of the object and height of the image negative. So like coordinate axis, positive x-axis, positive negative x-axis, positive y-axis and negative y-axis, as coordinate axis. Okay. So here we are considering, we are taking, we are measuring, we are taking as a reference point origin. Okay. With the help of origin, we are taking remaining measurements. Like along the, so this side positive x-axis, here positive negative x-axis, above it is positive y-axis, below it is negative y-axis. So same thing we will apply here. That's enough, nothing else, simple, very easy. So all measurements we are considering, we are measuring from the pole. Along the incident direction, along the incident rays direction, all are positive. The measurements are positive. Opposite to incident rays, the measurements are negative. Above the principal axis, so distances, height of the image and height of the object positive. And below the principal axis, height of the image and height of the object are negative. Okay. So these are the points. These are sign conventions. These are the sign conventions, right? So now we will discuss about mirror formula and magnification. Mirror formula and magnification. So mirror formula is 1 by f equal to 1 by V plus 1 by U, and magnification equal to height of the image by height of the object, that is nothing but minus V by U. Minus B by U. I hope it is very clear. Understood or not? Yes or no? So mirror formula, 1 by F equal to 1 by V plus 1 by U, and magnification equal to height of the image by height of the object, that is nothing but minus V by U. Is it clear? Right? So next one. Next one. Refraction. 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 Okay. So we'll discuss about refraction in the next class. If you like the content, if you like the channel, if you like my explanation, please do like, share, and subscribe to Student the Brand. And so just check the courses. So I'm starting the classes. Okay, so I'm going to start the classes. So regarding grade 10, you can check the channel banner. Okay, so if you need classes regarding grade 9, so you can do WhatsApp to this number regarding the classes for grade 10 CBSE physics and grade 11. Okay, for JE and NEET along with the CBSE. And after that, we will discuss about foundation classes for 6th, 7th, 8th, 9th, and 10th. Okay, for JE and NEET. Those are interested, those who want to take the classes from the Student the Brand channel. Okay, so you're always welcome. So join to the okay amazing experience with the physics classes. You can join to the classes and you can join to the course. So live classes will be there, interactive classes will be there. Okay. So topics will be covered, doubts will be clarified. So once you attend the classes, you are observing, right? You can see the classes, how it is going on. So each and every topic will be discussed in depth. So notes will be provided. Okay. So class notes will be provided and questions will be discussed. Okay. So everything. So everything we will do it in the class. If you like the content, if you like the channel, if you like my explanation, do like, share, and subscribe to Student the Brand. Inform to everyone, share to everyone, ask your friends to join to the class. So do like, share, and subscribe to Student the Brand. Thank you so much. This is your Sir from Student the Brand signing off. Thank you.